So in this problem, we want to solve an equation that involves a radical. Specifically, it involves a square root in this example. On the left-hand side of the equation, we have x minus 3. On the right-hand side, we have the square root of negative 5x plus 39. So there's a lot going in this equation. We've got variables on both sides. We've got a radical on one side, but not the other. So this is, as you might expect, a multifaceted problem. So before we do anything, let's think about what our strategy might be. It's a solve for x problem. So we know at the end of the day, we need to get x on one side of the equation only and by itself, unwrapped of all the arithmetic that might surround it. But because there's a radical there, we want to first deal with that radical to the extent that we can. And if we can manage to get this equation such that the radical is applying to the whole side of one equation, then we can get rid of that radical by taking a power of that whole side. And if I take the power of one side of the equation, I also have to take a power of the other side as well. Luckily for us, that square root is already isolated on the right-hand side of our equation, and so our first move is going to be to square both sides. As soon as I square both sides of this equation, that square root is going to disappear. But it does introduce a level of difficulty that I'm then also squaring the left-hand side, in other words, the binomial x minus 3. And if I'm going to square the binomial x minus 3, I better put some parentheses around x minus 3 first, or else I'm not really squaring the whole thing. And to square a binomial, don't forget, rewrite it and multiply it. Don't distribute the exponent because you'll fall into the purgatory of lost points. Okay, great. So then we're going to have an expression with a bunch of x's on both sides, maybe some x squareds in there because we will have squared out the binomial on the left. And so this feels an awful lot like a quadratic problem because I'm going to have some x squared terms, I'm going to have some constant terms, and I'm going to have some terms that just have single powers of x in them. So as with any good equation solving strategy, we want to subtract all terms to one side. And because this is quadratic, we're just going to go back to the quadratic strategy that we developed in Unit 2. First, we're going to collect all of our terms onto one side of this equation so that the other side of the equation is 0. And then simplify that equation so that it's in its standard form, so that we know how many x squareds we have, how many x's we have, and what our constant is. And the other side of the equation must be 0. And then, if it's going to be possible for us to factor in order to solve that equation, then we're going to do that. If not, then we might need a quadratic formula, but I don't think we're going to need that here. If we're able to factor it, then we just have to split it up and solve it by setting each one of the factors equal to 0 and solving for x. All right, so if it looks like there's a lot going on, that's because there is. Let's get started. So first, the right-hand side is the square root of an expression. Square root of negative 5x plus 39. That whole right-hand side of the equation is underneath the square root, which is great. We've got the radical right where we want it. And in our very first step, we're going to make it disappear. Because it's a square root, we can get rid of it by squaring the right-hand side and the left-hand side of this equation. Just raise both sides to the power 2. On the right-hand side, that's just going to make that square root go away. The square root and the square are just going to nullify one another and leave us with just minus 5x plus 39. Great. The radical is gone. We're never going to have to worry about it again. But on the left-hand side, we have the quantity x minus 3 squared. Again, do not forget those parentheses. We're squaring that entire expression. And because we're squaring that entire expression, we want to avoid the most common mistake to make, which is to try to distribute the power across addition or subtraction, which is illegal. And instead, rewrite it as a product. X minus 3 squared is x minus 3 times x minus 3. That reminds us, that triggers our Pavlovian response to FOIL, x minus 3 times x minus 3, which if we multiply it out, we'll get x squared, positive 9, and a pair of minus 3x's that turn into minus 6x. So x squared minus 6x plus 9 is what we get on the left-hand side. Negative 5x plus 39 is what we get on the right-hand side. Great. Now we've simplified the left and the right-hand sides as completely as possible. But we still have x's on both sides of the equation, so we have to collect all the terms onto one side, leaving the other side equal to 0. We can do that by adding 5x and subtracting 39 from both sides. That's going to give me, when I combine like terms on the left side, x squared minus 1x minus 30. And on the right-hand side, because we've moved all of its terms, we end up with just 0. And that's exactly what we need in order to implement the rest of our quadratic strategy. X squared minus x minus 30, we can look at and say, can I factor? And the answer is yes. We can factor by finding a pair of numbers which multiply together to give me negative 30 and which add together to give me negative 1. And a few moments of reflection will show us that plus 5 and minus 6 fit that bill. So we can factor the left-hand side into x plus 5 times the quantity x minus 6. And because that right-hand side is equal to 0 and the left-hand side is factored, we can split into two factors, x plus 5 and x minus 6, each of which gets its own 0. That's the zero factor property. We can solve each of those equations then to get the x by itself by just subtracting 5 in the first equation, adding 6 in the second equation, and getting the solution x is equal to negative 5 from the first equation, and x is equal to positive 6 from the second equation. And that's that. So how do I solve a radical equation if I have a square root of an entire side of one part of the equation? Well, to get rid of that square root, square it away. Just square both sides of the equation, and immediately that radical is gone. Once that happens, this becomes a garden variety solving a quadratic problem, for which we had to first simplify both sides completely, then collect all the terms onto one side of the equation to leave the other side equal to 0, and then simplify to the extent that we can, factor if possible, because we have a 0 on the other side of the equation. Factoring will actually be useful for us, which it was here. We were able to factor into x plus 5 times x minus 6. And because that 0 is on the other side, we can then split that apart to get either x plus 5 is equal to 0 or x minus 6 is equal to 0, from whence we get the two solutions, x equals negative 5 and x equals 6.